All right, guys. So this video is meant to help with, right now, I think it's number 11 on the motion worksheet, but potentially if you see this in the future, it's a problem in which an object is thrown up into the air, and we are trying to figure out things like what's the max height that it goes to and what's the total time. Okay. You can also see a problem like this, I feel like, right now on number 7 on the intermediate worksheet. Again, it's the Autobot problem, or in the future, a situation where there is, well, let me show you, and I'll try to make the translation later. Okay, so as you're looking at the screen right here, the motion worksheets, pull that up. We're doing number 11. So one of the Ulysses throws a Spanner's mug straight up into the air, 22 meters per second, single teardrop. She's 4 meters tall. No, she's not. How high did it go? And how long before returning to her hand? How long will it take to hit the ground? Oh, I didn't realize that there's this one too. So what I'm going to do right now is I'm going to split this video actually into 2 videos, so you don't necessarily need to watch this one. This video is specifically on how to set up that kind of little bit more difficult math that we talk about at the end of this one. If you know what I'm already talking about, then you can skip to the other video. If you need help setting this up again, then we'll talk about it. All right, so let's go ahead and switch screens here to just the camera, maybe. Is that right? Just the camera. There it is. Okay. So in this problem, we have being a mug being thrown up in the air at 22 meters per second. I'm going to establish that actually the ground here is 0 and that up is positive. Okay, and let's see what we know. Velocity initial, this should be easy since up is positive. It is a positive 22 meters per second. Okay, it's a little bit tricky, so I'm going to skip past that one. Acceleration is definitely negative 9.81. If you had made down positive, both of those two would be flipped. I definitely would not do that. Okay, now, when you're doing this problem, it is important to know what kinematics can do. Okay. What you're doing when you do kinematics is you kind of have to set up where is my initial spot and where is my final based on what it is I want to find. So if I want to find the max height, I'm probably going to set this spot right here as my initial. But the spot that's my final for that question is going to be the very top. Now, I don't think that the object is going to end up there. It's not going to end up there finally. I'm just saying this is the last spot that I'm looking at. By doing that, this would be my displacement. Okay, that would be this right here. The time would be the time it takes to get from there to there. And the velocity final is in fact the velocity up here, just because that's where I'm looking. So I would say velocity final there is 0. Now, the problem also says that the mug began 4 meters up in the air. A lot of times people want to take that 4 meters and plug it in right in here for displacement. Okay, and the reason you know that's not the case is A, the picture, you can see it. That's not the displacement. That's not the change in position. The initial position is there. The final position is there. This does not describe that at all. So it's not going to go there. Okay. Also, you can see over here, we've already got 3 variables. Plugging in a 4th kind of confuses things. Once we have 3 variables, these 2 have particular values. Okay, so what we're going to do is we're going to figure out what the displacement is simply by using this equation. And velocity final is 0. I'm going to subtract that term on both sides. And then to find displacement, I'm going to divide by this. Now, when you do this algebra, quick heads up, this negative is not being canceled by that square. Okay, this is only squaring what's inside the velocity initial, and that's very important because when we plug this in, what we get is negative times 22 meters per second squared. You'll notice my use of parentheses because we've plugged something in, divided by 2 times negative g is equal to the displacement. So this 22 squared, it's important that that negative doesn't cancel because actually you see we have a negative down here that it should cancel with. If I'd done this incorrectly, I would have ended up with a negative displacement, and I would have known that's not correct because the object is in fact traveling up in the positive direction. If I'm not mistaken, this ends up as 24 and some change, but let's go ahead and figure out specifically 22 squared, negative of that, divided by 2 times 9.8 and I end up with 24.7 meters positive. Now, the question that was asked is not what is the displacement during this time, it's how high does it get? Or in other words, what's the distance from here to here? Kinematics is limited by only being able to tell me displacement, but I can easily see that this is the initial position. So the final position is initial position plus change in position, or 4 meters plus 24.7 meters. So a total height of 28.7 meters is the height. Now, that's not usually the spot that people struggle with. The spot that people struggle with is the next question of how much time. Okay. Now, what you can do, and they asked a couple questions here. I'm going to skip one of them. One of the things that it says is how much time to get back to the hand. Do I want to skip that one? No, I'll show you both. Okay. But let's talk about how we can do this. We were just going from here to here. If we want the total time to get from the mug there all the way back to the hand, then that's an entire path, and that sort of can't be the final. Ultimately, we want the final to be right there. Okay, so we have two options on how we can do this. The first thing that we can do is we can split it up. We can split it up into halves. Okay, the first half would be it going up. I kind of already have that set up over here. This is on its way up. The second half would be on its way down. For its way down, the velocity initial would be 0 meters per second. The velocity final, I'm not sure about that. Acceleration would still be negative g. Delta t, not sure. And displacement, that depends on where we're looking. If we want to go back to the hand, well, then this displacement would just be the negative 24.7 because it rose 24.7 meters positive above that. So on the way down, it would be negative 24.7. To calculate the total time, we have to know this is the time to go up. This is the time to go back down. Yeah, so we would use the equation. What would we use? We just use this equation. Let's eliminate this. Initial plus acceleration times time. On the way up, velocity final would be 0. Subtract that over. Negative initial velocity equals a over t, so divide by a would give me the delta t on the way up. This would be negative 22 meters per second over negative g, which is going to be roughly 2.2 seconds. 2.22, if I remember correctly. 2.24 seconds. Okay, but that is for the way up. The way down, very, very similar here. Now the velocity initial cancels. Oops, I don't know that, do I? I don't know that. I shouldn't use this equation. Okay, the equation I have for that is this guy. This would be 0. Okay, and we're trying to find that squared. 2 times that divided by a square root. That's delta t. So 2 times negative 24.7 meters over negative g square root. And actually, if you calculate this, it also ends up as 2.24 seconds. Add those two together, and you can get the total time. The only thing that you're going to switch here, if instead of going to the hand, you go to the bottom, is just this. On the way up, it's going to be exactly the same, so don't need to change this part at all. The way down is going to change because rather than starting my initial for the down here and the final be back at the hand, I'm going to make the final down there. So before I said this was negative 24.7 meters to get back to the hand. Now to get to the ground, that is negative 28.7 meters. And the great thing about the way that I set this up is quite literally I know this number is going to stay the same. This number is the only one that's going to change, but I've already done the math, so all I got to do is go, hey, if this is 28.7, what's the way back down? 2 times 28.7, or negative 28.7, divided by negative g, and now we get 2.42. Coincidental that those just switched. Now the total time is not this one, it's not that one. It asked for the total time, so I'm going to add them together. So the total time it would take to fall is 4.66 seconds is how long it took to hit the ground. The first one I think was 2.48 seconds to come back to the hand. Now, I am going to show you a second way to kind of do this particular setup in the next video that connects directly to that math I was talking about. This problem, I told you at the beginning I was going to connect it to other ones. Actually, I'm not going to. I'm sorry. I was incorrect. I'm going to connect it to other problems in the next video. So this just specifically shows you how you can do it. You can do it in 2 separate steps. The next video will basically show you how you can do it just with 1 set of variables.